In problem 18, we're going to make an amide. The synthesis of the amide is going to be very similar to what we saw in the esterification. Now, I'm going to zoom in to actually look at how these atoms are going to form the amide and the HCl. So, if your amide has the hydrogens together, I'm going to rewrite this to make it more clear. Instead of writing it as NH2, I'm going to extend the two hydrogens. So I just turned that NH2 into this drawing. The HCl comes from the Cl in the acid chloride combining with one of the hydrogens in the amine. So that's what forms the HCl. Then I'm going to draw my acid chloride up until the carbonyl. So you can observe that this part of the molecule is what I drew right here. Next, I'm going to write a bond to connect to the nitrogen. This is my nitrogen that only has one hydrogen and it has the rest of the molecule. And that's exactly what I'm going to draw. Nitrogen with one hydrogen. And then I'm going to draw the rest of the molecule. Understand that these molecules, even though at first sight you would be like, that's not the same. In a way, they are. Let me make it more explicit. Let me just erase this. This is the nitrogen connected to the hydrogen, connected to a carbon that has a CH3 and an ethyl group. To write it more neatly, this symbol is just redrawing, meaning this. That just means a redraw. This is the same molecule. Because if we follow through it, this NH is this NH. This carbon is this carbon. Is connected to a CH3, which is here. And on the other side, two carbons, which they're here. So that's just another drawing from the molecule that I drew originally. Okay. So going back to the current amide, this part of the molecule is the one that I already drew. In order to write the amide, I'm going to connect that to the nitrogen. And remember that if you have an NH2, you can just take the 2 out and bond it to the hydrogen. Different from the acid chloride, if I combine one hydrogen to OH, instead of making HCl, in this amidation, I'm going to make water. My nitrogen atom still is connected to one hydrogen, and then the rest of the molecule. So I have my nitrogen connected to a hydrogen, and then I have 1, 2, 3, 4, 5, 6 carbons. So this is 1, 2, 3, 4, 5, 6 carbons. And this NH has 1, 2, 3, 4, 5, 6 carbons to represent the portion that came from the amine. And that's how you predict the products for esterification and amidation. Now let's look at the hydrolysis of esters. Esters can be hydrolyzed in the presence of acid or in the presence of base. In acid hydrolysis, we are going to utilize strong acids, and they are going to be the catalyst in order to take esters to form carboxylic acids and alcohols. Base hydrolysis of an ester is a reaction that has a name. It is called saponification. In saponification, we are going to take our ester and we're going to react it with aqueous, strong bases, and it could be sodium hydroxide or potassium hydroxide. In the hydrolyzed form of an ester, what we form is a carboxylic acid salt and an alcohol. Base hydrolysis of an ester is actually the reaction that it is utilized in order to make soap. Let's look at some examples of predicting the products to see how we are going to write the products of either acid hydrolysis of an ester versus base hydrolysis of an ester. These examples are from the in-class worksheet. So in reaction 20, we have an ester in the presence of acid, water, and heat. That means that reaction 20 is going to be the acid hydrolysis of an ester. In order to write the correct products, let's note that what we form in the acid hydrolysis of an ester is a carboxylic acid and an alcohol. So when we look at our ester, and I'm going to zoom in, what we're going to do is create a line that is going to separate the C double bond O from the single bond oxygen. When we do that, wherever we have the single bond O and the rest of the molecule, that is going to be basically forming the alcohol. So when I draw the product of this reaction and I draw the alcohol, I'm going to redraw my molecule up until the O, and to make it an alcohol, I'm going to add an H to the oxygen. In order to write the carboxylic acid that results in this molecule, I'm going to draw my molecule up until the C double bond O, meaning I'm going to take this C double bond O, connect it to a carbon that that carbon has 2 carbons attached to it. And to make it a carboxylic acid, I'm just going to connect it to an OH. And that's how we draw the product of an acid hydrolysis of an ester. Let's now proceed to do the base hydrolysis of an ester. In the base hydrolysis of an ester, remember that our base is going to be aqueous. And when we take our ester and we put it in strong base, which could be sodium hydroxide or potassium hydroxide, and we heat it, we're going to hydrolyze our ester. Similar to what we did in the hydrolysis of an acid, we're going to write a line in between the C double bond O and the single bond oxygen. Wherever we have the single bond oxygen, that is going to be the alcohol that will form. Whatever we have, the C double bond O, that's going to be the carboxylate salt that forms. And this is how we draw it. The alcohol is going to be oxygen bonded to that line. Remember that that line means that there's a CH3 there. And to draw the alcohol, I'm going to add a hydrogen to it. The carboxylate salt is going to be where I take my double bond O, meaning this part of the molecule, and I do 1 carbon, 2 carbons, 3 carbons. 1 carbon, 2 carbons, 3 carbons. And to write it as a carboxylate salt, I'm going to write a single bond to O minus. And since my base has specifically sodium, then I'm going to write sodium as a cation. And that's how you predict the product for the saponification of that ester.